Hello, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to Crystallography and Bonding in Solid course. This is the third lecture of the course, and in this lecture, you will learn on the concept of symmetry in crystal. But before that, let us watch on this video. What can you see from this video? The beautiful snowflakes falling down. And if you observe, the snowflakes has a very unique crystal. Isn't that amazing? Regular arrangement of atoms and molecules in matter is evident in the crystal morphology, or habit of many materials from snowflakes to many common minerals. And in this lecture, you will learn on the concept of symmetry. Before that, we will learn on concept of lattice and seven crystal system, including the characteristic and minimum symmetry elements, followed by concept of symmetry, and finally, basic symmetry elements. So, again, what is crystal? Crystals are made of infinite number of unit cells. But what is unit cell? Unit cell is the smallest unit of a crystal, which, if repeated, could generate the whole crystal. This is an example of crystal. A crystal unit cell dimension are defined by 6 numbers. The length of the 3 axes A, B, and C, and 3 interaction angles alpha, beta, and gamma. And these usually termed as lattice parameters. A crystal lattice is a 3D stack of unit cell. Crystal lattice is an imaginative grid system in 3 dimensions in which every point has an environment that is identical to that of any other point. Here are the 7 crystal systems. So we have cubic, hexagonal, tetragonal, rhombohedral, orthorhombic, monoclinic, and triclinic. The difference between them are the axial relationship and interaction angles. You need to learn how to draw all the 7 crystal systems, but to do that, you need to know the axis and the angles for each of the crystal. For cubic, A equal to B equal to C, and they are all perpendicular to each other. So this is the crystal of cubic. Then we have hexagonal. A equal to B but not equal to C. A and B are still 90 degree or perpendicular to each other, but C is 120 degree, which give you the gamma. So this is the hexagonal crystal structure. Then we have tetragonal. Again, A equal to B but not equal to C, and in this case, alpha equal to beta equal to gamma equal to 90 degree. They are all still perpendicular, but what is the difference between tetragonal and cubic? One of the axes, which is the C axis, is now elongated slightly compared to A and B. So this gives you tetragonal. Make sure you draw clearly tetragonal and cubic so you can see the difference between the two. Then we have rhombohedral, where A equal to B equal to C, but they are all not 90 degrees, so they are a bit skewed. Then we have orthorhombic. A not equal to B, not equal to C, but the angles are all perpendicular to each other. This gives you orthorhombic. Then we have monoclinic. Again, A not equal to B, not equal to C, but alpha and gamma equal to 90 degree, but they are not same as beta. So this is monoclinic. And finally, you have triclinic. Same as monoclinic, A, B, C, all are not equal. And for triclinic, the symmetry is even looser, where alpha, beta, and gamma all are not perpendicular to each other. So this gives you triclinic. And if we arrange this crystal in the decreasing symmetry order, this is what we get. So the most symmetric crystal is cubic. That's why cubic is also called isometric, because it has the same length, the same one length for all the axes, and also the angle are all 90 degrees to each other. So cubic is also known as isometric. Then we have hexagonal, followed by tetragonal, trigonal, orthorhombic, monoclinic, and lastly triclinic. So triclinic has the least symmetry as compared to the other 6 crystal systems. And these are some examples of crystal in real life that have the 7 crystal system accordingly. Alright, so that is the basic of crystal, and we will take a break and continue shortly.